Good day, everyone, and welcome to our Layfield webinar on Aqua Dam, Coffer dams for pipeline installations and repairs in and around rivers or standing water. My name is Eric Rangel, and I am the Marketing Manager for Layfield Environmental Containment, and I am the host and organizer of this webinar. This webinar will be about half an hour long, and again, it's going to be mainly about Aqua Dam, Coffer dams. You can see here in the picture, this is a fun project. This is an aqua dam that is blocking a stream to divert water. This is for a pipeline crossing installation. And the goal here is to create a dry working environment. You can also see sealed curtains and turbidity curtains in yellow and orange. And these are installed to prevent sediment migration from the construction area into the rest of the river. So this will protect the aquatic environment and prevent costly environmental cleanup work and liability. So again, today we're going to talk mainly about Aqua Coffer Dam for water diversions and aqua barriers during pipeline installation, inspection, and repairs in and around rivers, wetlands, and ponds. While this webinar is mainly about Aqua Dam, we will also take a couple of minutes at the end to talk about sealed curtains, turbidity curtains, as well as geomembranes for secondary containment applications in tank farms. So just want to introduce our presenter today, Greg Parent. He's our service group business manager, and Greg is responsible for driving sales and growth of Aqua Dam in North America, and he has been involved in dozens of Aqua Dam, Coffer Dam installation projects. So I will now leave you with Greg Parent. Thank you, Greg.
Thank you very much, Eric. So Aqua Dam, Coffer dams for pipeline installation and repairs. We're going to go through several applications and talk to you a little bit about how it works, as well as the actual installation steps, and move through into the silk curtains, turbidity curtains, as Eric has previously introduced. So how does Aqua Dam work? Well, Aqua Dam is actually built from a strong fabric outer tube, which has two inner polyethylene tubes inside of it. It's technically actually only one internal polyethylene tube that runs down towards the end, comes back the other side. They are open-ended tubes and do not require any specific valves, fittings, those kinds of things. So they're much more user-friendly than some of the other alternative water coffer dams on the market. Within the Aqua Dam itself, there's a vertical baffle, and it will lock in place as water levels increase on the one side of the Aqua Dam. In addition to that, the two tubes inside create friction to prevent rolling. If you've ever taken a couple of truck tires and put them side by side or end to end and tried to roll them, the actual friction of those tires on themselves prevent the actual rolling of those tires. So the Aqua Dam functions in a very similar fashion. In addition to that, the friction helps prevent helps to anchor the tube in place. Will generally protect against 75% of the Aqua Dam height. So if we're looking at a 4-foot Aqua Dam, we're going to go protect against 3 feet of water. So that's generally how the Aqua Dam how it works. Our standard sizes for Aqua Dams are 2-foot high, which protects against 18 inches of water, 3-foot high, which protects against 28 inches of water, 4-foot high, which protects against 36 inches of water, 6-foot high, good for 48 inches of water, and the 8-foot tall Aqua Dam is good for 60 inches of water. Again, these are our standard sizes that we have in stock. They come in lengths of 50 and 100-foot lengths. Custom sizes are available upon request, but they do generally require some type of a lead time. So if your project specifically required 260 feet of Aqua Dam, we could build that specifically for your project. We would just require additional lead time in order to produce that custom to our project requirements. We generally recommend having a Layfield representative come out to assess the overall length requirements and your project site to better provide a full understanding of what your project requirements are before ordering something of that magnitude. This is just a picture of our one of our 6x100 Aqua Dams inflated in the shop. That's a step that we do during final assembly as part of a a final inspection before rolling the Aqua Dam up and having it ready to go. Just a few other notes on sizes. Lengths can be joined end to end utilizing a connection collar, so you can kind of end up with almost an infinite length of Aqua Dam connecting them end to end. In addition, you can connect off of the side of an Aqua Dam to isolate a specific shoreline or bridge pier or those types of things. Those are just a couple of methods that you can utilize for joining Aqua Dams. Larger sizes are available. 10-foot, 12-foot, 16-foot high Aqua Dams are available. Again, custom lengths are available, upwards of 1,000 feet for when we're dealing with 10-foot, 12-foot, and 16-foot. It's awfully difficult to do connections in really deep water, so custom lengths are available. Generally speaking, when we do flood control, we can make up to 500 feet, and the only reason we put the 500-foot limitation on is because usually a flood control dam is we try to limit it to 500 feet because it becomes unmanageable from a manpower perspective on site to do things much larger than about 500 feet. So we can kind of custom make anything that you do require from a dam lengths perspective. This is a picture of a 12-foot high by 300-foot long Aqua Dam, which is being used to isolate the spillway of a hydroelectric dam. They're doing refurbishing of some of the spillways or some of the actual locks, and they needed to put the Aqua Dam in place to prevent water flow into the work area. So when we're looking at an Aqua Dam, we like to get as much information as possible to properly assess and evaluate the project to ensure the highest level of success when it comes to your project. The information that we gather are things like location, installation date, installation duration, and the reason we kind of gather some of that information, location specifically, so that we can actually try and draw some hydrological information off of the web from Environment Canada with rainfall, stream flow, those kinds of things. We'd like to get an accurate and maximum water depth of the stream or lake that we're working in, just so we have a good idea as to, you know, during peak runoff season, what potential could we see there. And the installation duration plays into that, because if it's an 8-month installation, then we have to look at the 8-month window and determine, you know, where are we actually falling into as far as potential flows and water depths. Where are we actually going to be working? That's what we need to design the actual Aqua Dam to withstand. What type of water body are we dealing with? Are we dealing with a lake or a stream, a river? Stream and a river are two different things. A river is a much more prominent major water body than a stream would be from my perspective. How much of the percentage of the water body are we blocking? We generally don't like to block more than 50% of a stream or river. As we block more than that, Department of Fisheries and Oceans has issues with that, especially if it's navigable waters. And then the water depth actually increases and the velocity increases as well as we block off more of the channel than about 50%. So it's just we like to stay within 50% of the stream, blocking off not more than 50% of the stream. I'd like to know about the water velocity. Because installation of an Aqua Dam in waters, you know, above 1 to 1.5 meters per second becomes quite difficult. It's not impossible; it becomes fairly difficult, and a lot of things need to happen to make it achievable. Meter bags in the water, those kinds of things. Surface conditions: we're looking to figure out how much seepage are we going to see underneath the Aqua Dam. Are we going to get a really good seal of the Aqua Dam on the rocks or silts or whatever the stream bed is? And then how are you looking to divert your flow in moving water applications? Are you looking to utilize some kind of pumps, some kind of diversion channel, pipes, superflume? What are you looking at there? We always like to get drawings, sketches, pictures are with 1,000 words, and then any kind of hydrological information that you might have relating to stream flows, those kinds of things are valuable pieces of information to enable us to evaluate each project on their own merits, as opposed to kind of a broad brush Aqua Dam is going to work in every application, because There's some scenarios where stream flows and those kinds of things are too great for Aqua Dam, where the stream is too narrow for an Aqua Dam to do a shoreline restoration project, let's say. Just things to consider, and that's why we get the assessment form filled out. Is there a nice elevated starting point that we can start the Aqua Dam off of? Reasonable subgrade, and what kind of flow rate information do we got? So again, just some information we look at for from an assessment perspective. So these are just an example of a project from an assessment point of view. On the left here, we've actually got a beaver pond that they needed to do an isolation on for some pipeline work. The beaver pond had lots of trees, stumps, branches, bogs, cattails, those kinds of things in the pond along the edge that would have caused issue from a seal perspective, and potentially, when you talk about stumps and tree limbs and stuff like that, potentially even puncture the Aqua Dam as you roll over it. There's lots of pressure vertically from the top down onto the base, and running over top of those kinds of things could actually damage the Aqua Dam. So in this case, they actually used the long stick excavator and pulled out as much of the stuff as they could. They've got a silt curtain in place to prevent silts and sediments from actually migrating into the rest of the pond. They used the long stick excavator to pull all of these stumps and trees and bulrushes and everything out of the pond to create a flat, clean work area. On the right, you can see our starting point is cleared off. You've got good elevation change. You've got nice and smooth. So we're going to start our Aqua Dam on the right. We're going to run down into the water. And this Aqua Dam is actually a 10-foot tall by 1,050-foot Aqua Dam. So we're going to go shore to shore 1,050 feet to isolate a pipeline project. So we're going to look a little bit about applications for pipeline installation and repairs, where we're going to use Aqua Dams, how we're going to use them. So we're going to use Aqua Dams for isolation of stream crossings. So either new installation or pipeline maintenance, we're going to actually isolate a stream to allow for an open cut pipeline installation or open cut pipeline maintenance. We're going to put an upstream Aqua Dam in place. We're going to put a downstream Aqua Dam in place and utilize some type of diversion method, whether it be pumps and hoses. As you can see in the bottom left, they've actually got some pumps moving water around the work dig site. And the bottom right, they've actually got two super flumes installed with they're actually pre-constructed, pre-manufactured flumes with wing walls at the front to divert water flow into the flume itself. We've got Aqua Dams on either side running out upstream and downstream to direct flow into the super flumes. So just a couple of methods of isolating or diverting flow in a stream crossing application. We've done many of these with Aqua Dams in the past over the last 20 years. Then we're going to talk about isolation of sloughs and ponds. So non-moving water applications, generally, again, open cut installation and maintenance. You've ran inspection and you've determined that you've got corrosion or you've got a dent or you've got some type of work that needs to take place, either through sleeves or putting a sleeve on or doing some kind of a sandblasting and recoating or whatever. You need to isolate that pipe so you can work in the dry to create that, to do that maintenance. You put an Aqua Dam in either through the slough, create a U configuration around the shoreline to isolate your work zone, pump that area out, and now you've got a free dry work area that you can actually do your maintenance. So on the left, you've got a picture of actually an Aqua Dam running right straight through a slough. They end up pumping out the right side of the picture, the right side of the Aqua Dam, to allow for pipeline maintenance through this slough. And then in the middle and right pictures, two different projects. We've actually done a U configuration Aqua Dam where they've actually done maintenance on both scenarios, pumped the water down on the inside, and then did an open cut to expose the pipe, and they did some sleeving work in both scenarios. The isolation of exposed pipelines. So you've got a pipeline that over time is within a stream, and over time, floodwater or high water levels, during spring runoff, those kinds of things over time has exposed your pipe. You got to recover that pipe somehow. So we're going to isolate a section of your stream, section of the shoreline to enable you to actually recover that pipe, shore it up, armor it in the dry so that you can then have a good level of protection of that pipe over in the long term. Isolation of for emergency response and for flood control. So if you've got a pipeline that's malfunctioned, or you've had a pipeline that's actually corrosion has gone right through, you've got some leakage, a spill in wetlands, in muskeg areas, put an aqua dam in place to prevent any chemicals from entering into a water body nearby, or restrict any further contamination of your muskeg area or wetland. Put an aqua dam around the area to isolate it. In addition to that, you can actually use aqua dams in a flood control type of perspective to protect valuable and critical site infrastructure from flooding. Pump buildings, pump shacks, manifolds, pump stations, and even to some degree even tank farms. Even though they have dikes around them, generally speaking, you could utilize an aqua dam to prevent flooding from occurring or from hindering that operation. So in this scenario here, we've actually got an aqua dam around Fort Calhoun nuclear plant. This was back in 2014, I believe. Fort Calhoun has since been decommissioned. However, at this time of this picture, we actually did a lot of protection. You can actually see 3 actual areas that are protected. On the far left, we've got a building, and the white building is protected. Top of the slide, we've got a building that's protected, and then the main actual nuclear power plant is actually protected by an aqua dam there too. This is in Nebraska along the Missouri River. So the Missouri is a large water body and sees flooding quite regularly. So we protected this nuclear power plant from flooding. So in a flood control application or emergency response application, aqua dams are reusable. They can be cleaned off, cleaned out, and then stored away out of the UV. You can reutilize them several times over several years. I've seen them get put away and then be reutilized again 8 years down the road. So they are definitely storageable and reusable, especially when we talk about emergency response and flood control. There are definitely less cleanup costs associated with aqua dams than there would be associated with sandbags or some kind of a sand or dirt berm that you might construct to prevent flooding from occurring. Interesting fact: 75% of all damage from flooding is actually caused by less than a foot of water. So you don't require a ton of protection to actually eliminate the actual damage that could occur as a result of flooding. So aqua dam installation, we're going to talk a little bit about how aqua dams are installed. So just number one, installation starting point. We need to have an elevated starting point. As I said in the beginning, aqua dam is an open-ended tube. It does require an elevated starting point. It doesn't have any kind of fittings or anything. You're going to take your pump hoses and put them down into the open-ended tube, tie off your aqua dam to a pipe of some kind along the top, to prevent it from unrolling in moving water situations. So you're going to actually pump water into it and prevent it from unspooling itself off of the core to get some head pressure so that the current in the stream, the moving stream, does not wash it downstream. So that's kind of what we've done here in both of these pictures. We've looped the rope down underneath the aqua dam and up on top to prevent the unspooling of the aqua dam during the filling process. So number two, the filling of the aqua dam. We've got our hoses on the left here. You can see we've got the hoses that run down into the polyethylene tubing, and actually you can kind of see it in the bottom left corner of the right picture as well. We've got our ropes running out underneath and back coming across the top. That prevents it from unspooling. One of the key components here is that we want the aqua dam to enter the water perpendicular to shore. We don't want it off skew anywhere, because it could actually, the water flow could actually direct it in a different direction from where you wanted it to go if it isn't coming off of shore perpendicular. Connections, number 3, we're going to do a connection. So each aqua dam has a connection collar, and it's basically made from the same material as the aqua dam outer skin is. It extends 15-ish feet onto past the end of the first aqua dam. You run the second aqua dam polyethylene tubing into it, make a couple of holes along the top to pull the polyethylene tubing through up into of the second aqua dam. You'll then put your fill hoses down into the polyethylene tubing of the second aqua dam, and you can basically start the filling process. So inserting the hoses into the second aqua dam and continue the process. In both of these situations, we're basically dealing with non-moving water, so they don't have the ropes in place to prevent it from unspooling. On the left, that's actually a pipeline dig in Saskatchewan through a slough. So there's no moving water in this slough. Base of the slough was very consistent, so we could just let the aqua dam unroll itself, utilizing the water itself. On the right, that's actually in the North Saskatchewan River. The installation of the first aqua dam has blocked flow off so that the second aqua dam installation is in non-moving water. It's all stagnant water in there, so they didn't require the ropes to restrict it from unspooling during the installation process. So they basically are just filling that aqua dam as if it was in non-moving water, even though it is actually in a river. So once we got the aqua dams in place, then we got to worry about how we're going to deal with water flow. How are we going to divert the water around your work site? There's different methodologies behind that, everything from pipes to flumes to pumps to diversion channels. You can see in the top left, we've actually, in this installation, they've utilized an 18-inch diameter pipe. They've weighted it down on top, and they've got water diverting around their work site through that pipe. In some scenarios, we've actually ran a couple of aqua dams and run the piping underneath the aqua dam. There's different methods depending upon the type of flow, depending on the size of the stream, different ways we can do the pipe work. Top right, we've got a couple of superflumes in place with a front wing wall diverting flow into the superflume. We've got aqua dams running out to it in upstream and downstream scenario, and we've got 2 excavators working on either side doing their work. The bottom left picture, we've got 6 pumps, submersible pumps that are going to divert flow around the work site. So prior to the installation, we're actually going to turn those pumps on, because we want to start diverting the flow before we actually install it, because as you can see, 6 submersible pumps, 8-inch in size, there's a substantial flow there. The second we put the aqua dam across, we're actually going to be potentially washing out that aqua dam if we don't have those pumps on before we start actually installing the aqua dam. So that's something we need to consider during the installation process, is when do we turn those pumps on. Generally speaking, it's going to be before we start the installation of the aqua dam. The bottom right picture, we've got another pump diversion project. We're diverting water flow. We're putting it into a sedimentation basin to allow any silts or anything that are being pumped out of the creek to get dropped into the sedimentation basin. The water then flows from the sedimentation basin back into the stream, and they're isolating their work area. So that's what that picture is it kind of shows a sedimentation basin where they've got some hay bales pumping water into it. It's filtering the water, and cleaner water meeting their suspended solids requirements are actually being passed into below the downstream aqua dam and continuing on in the stream. So sediment control near water bodies. Silt curtains, as Eric had talked a little bit about during the beginning of the presentation, silt curtains are used to control silt when working in low flow or standing water applications. So you're working on a shoreline or something with very little flow or no flow. A silt curtain is going to prevent particulate materials from leaving the construction area, getting into your stream, contaminating it fish or other type of wildlife, frogs, ducks, those kinds of things. Custom curtains can be made to accommodate any water depth that you might have, and in addition to that, even custom lengths. If you require a custom length floating silt curtain, we can absolutely do that as well. So just a few little things. Silt curtain is much of a shorter term use than potentially than what a turbidity curtain would be. So a turbidity curtain are deployed in areas where their sediment discharge to a stream is unavoidable. In addition to that, they're a lot heavier duty, used for higher flow applications. So if you've got a lot higher flow in streams, or you've got tidal action, that's where you're really going to look at utilizing a turbidity curtain as opposed to very low flows or standing water. Turbidity curtain is also going to be a longer term solution. It's going to be in place for a lot longer than a floating silt curtain would. They can be used in slow-moving water or in rivers and with flow rates of up to 5 feet per second. Again, tidal water is another one that we can use them in. And really, when we talk about turbidity curtains, there's kind of 3 different grades, let's call it, of turbidity curtains, depending upon your flows, your longevity, tidal water, those kinds of things. We're going to look at different grades of turbidity curtain to meet the needs of whatever application you actually have. We're going to talk a little bit about geomembrane technology for tank farms, for terminals, those kinds of things. And Layfield is actually a manufacturer of geomembranes. We make standard grade HDPE, standard grade linear low density polyethylene. But what we really try to focus on is a fortified geomembrane technology, which introduces advancements in resins and UV antioxidant stabilization packages. It utilizes multi-layer co-extrusion technology and superior performance properties such as multi-axial elongation, HPOIT, and other types of superior performance properties that make it more fortified than the standard industry grade geomembranes that are produced. One of those materials is heat guard HDPE. It's uniquely resistant to higher temperatures and can be under continuous use at 185 degrees Fahrenheit, 85 degrees Celsius for over 20 years. So in pipeline terminals and tank farms, if you've got heated tanks and stuff, this is something that's could be fairly beneficial for your use. It's got excellent chemical and UV resistance, good hot liquid resistance as well. So just something to consider when you're looking into putting a liner in on secondary containment within your terminal and tank farm. So the actual construction and maintenance in terminals and tank farms, we've done work utilizing our EnviroLiner as well as HDPEs in pump stations and manifolds, as well as wet ponds, runoff ponds, and ditches. So lots of non-secondary containment applications, we've utilized within tank farms and terminal sites. In addition to that, we have done a lot of secondary containment under tank liners. You can see this picture here is in the middle of winter, doing an under tank liner prior to tank erection. On the right, once the tank has actually been completely installed and you've got some piping in place, we've come in and we finished the tank farm off. So, generally speaking, terminals and tank farms are a multi-phased type project, and we can definitely take part in all of those phases and give you a good installation of your whole system.
Thank you very much, Greg. Thanks for a pretty good presentation. So again, at Layfield for environmental containment, we are a very good choice for all of your midstream oil and gas needs. Again, this presentation mainly about aqua dams, but also our geomembranes for tank farms and other specialty geosynthetics. There are different things that set us apart as a company. One of the things that differentiate Layfield is that we are vertically integrated. That means that we are involved in manufacturing, fabrication, installation, and maintenance of geomembranes, floating covers, and aqua dams and specialty geosynthetics. Our geomembranes are also another thing that sets us apart as a company. We manufacture fortified geomembranes, and fortified geomembranes are geomembranes that are formulated with special resins and special additives that provide enhanced UV, heat, and chemical resistance properties. So we are also a global leader in floating cover systems, and we have been involved in over 100 floating cover projects in North America, South America, Australia. And we provide specialty geosynthetics such as aquadam, geotubes, and others. And we also provide repair and maintenance services for our containment systems. At Layfield, we protect. Our business is to provide products and services that protect our families, our communities, and our environment. So for instance, our geomembranes protect our environment from accidental contamination. Our floating covers keep our drinking water safe. And our aquadams, flood control aquadams, protect homes, businesses, and communities from flooding. So thank you very much, everyone, for your time attending this webinar. We appreciate your time. If you have any questions about any topic discussed in this webinar, or if you would like to discuss a particular specific project, please send us an email to containment@layfieldgroup.com, and we will answer your questions. We will get back to you within 24 hours. On that email, you can also contact Greg Parent, our presenter today. Again, it's containment@layfieldgroup.com. And please also contact us if you would like to have a copy of this presentation. And finally, I'll invite you to visit our website at layfieldcontainment.com. And here you can find additional information on aquadam, coffer dams for pipeline installation and repairs, additional information on our geomembranes, floating covers, turbidity curtains, silt curtains, etc. So again, thank you everybody for your time and have a great day.